Hello, welcome to the Alliance HPLC System Operation and Performance Maintenance course. My name is Kip Bagaglio. I'm the instructor for the course, and this course is built around performing the performance maintenance for the Alliance HPLC separations module. The course will cover an overview of the system, a theory of operation, how the pump operates, how it makes an injection, and so on, configuring the system, and then we go through actually doing the maintenance procedures on the instrument. With that, we'll take a look at Chapter 1, which is an overview. This first slide shows a drawing of the Alliance separations module. There's a space on the top for a detector and for a set of solvents. There's a front panel which has a display and a keyboard, and this is how we'll be using the machine. Typically, the machine is being controlled through a computer, but all the diagnostics and internal tests are done through the front panel. On the earlier versions, on the outside, there was a floppy disk drive. This machine came out back in the days before there were a lot of computers in laboratories, and machines weren't networked. So the machine was designed for standalone operation, and the floppy disk drive, you could create a method for performing a separation on one machine, export it onto a floppy disk drive, sneaker net it across the lab to another machine, and install on the other machine. It eliminated having to transfer information on paper, and transcription errors and things like that were eliminated this way. There's a sample compartment. It holds 5 carousels. Each carousel holds 24 samples. So you have a total of 120 samples that can be used on this machine. Down the bottom, on the left, is a solvent delivery access door, and the solvent delivery system is the pump. And then there's also a solvent conditioning tray. The solvent conditioning tray includes the degasser and the gradient proportioning valve. To the right, there's an optional column heater that can be plugged onto the machine, and it can take up to 300 millimeter columns inside. Also available inside this machine would be an optional column switching valve to allow you to switch between multiple columns. This next slide shows a cutaway view of the instrument. There's a CPU board, and there's a battery on that CPU board that maintains things like the date and time and a number of internal information pieces for the machine. That battery is replaced as part of the PM, and later on we'll be showing you how to do that. There are a number of options available with this machine. There's a sample heater cooler, and that usually comes with the machine when you purchase it. It can be added on later in the field, but it requires a service engineer to make a call. There's a column heater and a column heater cooler. Those devices can be added on at any time. It's merely an external cable connection. There's a column switching valve, as I mentioned, and there's also an optional barcode reader. Now, the barcode reader was designed for the idea of environmental or forensic work. The reader is installed in the machine because when a sample is taken, anytime a sample for forensic or environmental, something that requires a legal tracking, is passed from one hand to another, it has to be marked down what that sample is. Well, the barcode reader eliminates handwriting differences, transposing numbers, and things like that. In reality, I think I've met 2 customers who actually had one. The power connection on the back of the machine is for a 120 volt or to 240 volt, 50-60 hertz connection. All instrumentation today carries what's called a switching power supply. It doesn't matter how many cycles you have or what the voltage is. The machine will operate on any standard voltage that's produced. Above the power supply, there's an analog input and outputs. Now, Waters has this thing, what we call backwards compatibility. Early on in the days, before there were computers in labs, you would have this rat's nest of wires behind the instrument, and your injector would send the signal to a strip chart recorder or to an integrator in order to acquire the data. So there's still an injection output, there's still an injection stop, and switches that can be controlled by time. They still are used today, but not to the extent that they were years ago. There are 2 RS-232 ports, and a number of mass spectrometers and other equipment communicate through RS-232. This instrument shows the IEEE 488, which is a communications bus, and the newer instrumentation is controlled through Ethernet, and there's an Ethernet connection down the bottom. On the back of the instrument, there's a label indicating what those analog outputs are used for. Again, an inject start might be used for someone who's connected to a LIMS system, that is a laboratory information management system. The machine needs to tell the system when to start acquiring data. There's also a run stop. That run stop tells the LIMS systems to stop acquiring data. There are switches that can be controlled by time. For example, if the machine is being used to acquire in a preparative mode, sample is being sent to a fraction collector. Well, if you have a 20-minute separation and the peak you're interested in concentrating or looking for comes out between 12 and 14 minutes, there's no real need to collect 20 minutes of solvent. You can set the switch up to have the fraction collector go to waste initially. At 12 minutes, the switch turns on and the flow is diverted into the fraction collector. And then at 14 minutes, it goes back to waste. So you only collect the 2 minutes when your peak is actually coming off the column. There's a function underneath the inject start called stop flow. Some companies in the US and some in Europe, mainly the Scandinavian countries, require that you have a switch on your waste container that is capable of turning off the flow of the instrument in the event the waste container becomes full, so as to prevent an overflow and a spill from the waste container. There are a number of fluid lines coming into and out of the instrument. There are 4 solvent lines coming in. There's a solvent line for the plunger or seal wash, and there's a solvent line for the needle wash. Now, plunger wash and needle wash are typically different solvents. They have different purposes in life, and later on we'll be discussing about what each one is and how it gets used and why it's important to choose the proper plunger wash or seal wash. On the outflow, there's an outflow from the needle wash. There's an outflow from a purge or a waste from when you're priming the system. There's an outflow for the seal wash, and there's also a degasser vent tube. The solvent inlet lines are labeled as solvent A, B, C, and D. They also have different colors. A is yellow, B is blue, C is red, and D is green. And they have metal filters on the bottom. There's a plastic reservoir filter for the seal wash, and it's labeled with a label, again, as seal wash. There is a green 1/16 inch Teflon tubing, and that's the needle wash inlet. The outlet for the needle wash is a 1/16 inch yellow line, and the purge or waste line is a 1/16 inch clear line. Now, those are the same colors that have been on our systems since the very earliest days of our auto samplers. Again, with the idea of our backwards compatibility, customers would write procedures that did not say things like put the needle wash line into the needle wash reservoir. They would say put the green line in the reservoir and the yellow and the clear line into the waste container. So by keeping the same colors, the customer doesn't need to change his procedures. The 1/8 inch Teflon outlet line is for the seal wash, and the large clear tube is the degasser vent. The degasser vent can be run into a hood or to an area if there are problems with the vapors or coming off it, or it can be put into a waste container. However, be very careful if you put the degasser vent into a waste container. The end of the tube, the degasser vent, must not go below the level of the solvent. Otherwise, the degasser tube has no outlet, and the degasser becomes very inefficient at that point. Fluid connection to the column. Again, there's this little red sleeve on the tubing that comes out of this injector. That's because our early auto samplers did not have a pump connected with them. The pump was an external pump, and there were 2 lines. Both lines looked the same as their stainless steel tubing. The inlet line had a blue sleeve on it, and the outlet line had a red sleeve on it. Well, here there's still a little bit of a red sleeve on the outlet line. Again, people are writing their procedures saying connect the red line to the column so they don't have to change their procedures. When you first turn the machine on, the first thing that happens is the screen goes through all these kind of gyrations, and then it turns blank and it beeps once. And a few seconds later, it beeps twice. and after about 20 seconds it beeps 3 times. And then this screen comes up, and it tells you that the CPU, the ROM, the RAM, the keypad, the display, and all these other things are okay. What this means is it found that device inside the instrument. While the screen is blank and those beeps, the machine is doing an internal check of all these components. If something happens where something isn't okay, oftentimes in turning on the switch, if you hit the switch gently and don't get it on all the way, the machine starts to initialize, and then what happens is the switch breaks, it stops initializing, but the electrical capacitance of the system doesn't drain, and then when you hit the switch all the way on, what happens is the machine starts over again, and it has 2 starts on it, and it doesn't know what to do, and it gets locked up. So if one of these functions fails and it doesn't initialize, turn the power off. Wait 10 or 15 seconds to ensure that the electronics have drained completely of all the capacitance. Then turn the switch on smartly. If it halts again, doesn't have a problem again, try that one more time. If not, at that point then you have to call for a service engineer to come in because something's very definitely wrong with the CPU board. This is not something that happens very often though. This next slide shows a flow chart. When you first turn the machine on, the screen that comes up is what's called the main menu screen. And on the bottom of the screen there are a number of functions. Develop methods and run samples, those are for what's called standalone operation. Diag is for the diagnostics. Config is for configuration, and log shows logs of the instrument, what's happened with the instrument. Now the reason we show you this chart, Diag has a number of functions underneath it. Prime seal wash, compression check, adjust seals. These are not essentially diagnostics, these are functions, but we had to put them somewhere. However, under other tests, that's where most of the actual diagnostics are. Now, some of the things that are in there are, for example, one of the things is called head removal and replacement, and that's one of the functions we do with this course on rebuilding the pump heads, replacing the seals and the plungers and the check valves and such. Well, if you have to do that, you know you want to do the head removal and replacement. Head removal and replacement is under other tests. Other tests is under diagnostics. Diagnostics is under menu. This is a roadmap to get to the diagnostics. So from the main menu page, you press Diag, go down, press Other Tests, and find Head Removal and Replacement. And that's why it's in the book. A second page, on the front panel of the machine, there's a Menu Status button. If you press that button and you're in the menu page, you'll go to the status page. The status page gives you the direct functions on the machine, which are used for priming the instrument and for purging the instrument. You can also equilibrate condition columns, and there's a newer function called System Setup on that, and we'll cover that in the next chapter.